In the previous checkpoint, you have learned that a transformer is made from two coils of wire wound around a soft iron core, and that an AC current in the primary coil will induce an AC EMF in the secondary coil via electromagnetic induction. We have also briefly mentioned that the fundamental significance of the transformer is that it can change the peak voltage of an alternating current. However, we have not yet explored how the transformer does this. Before we begin, let us broadly split transformers into two main categories. Step-down transformers convert a higher voltage source to a lower voltage output, while step-up transformers do the opposite and convert a lower voltage source to a higher voltage output. Now let me explain how transformers is able to change the peak voltage of the alternating current. This is related to the number of coils of wire wound around both the primary and secondary coils, denoted by NP and NS respectively. Assuming an ideal transformer, there will be a magnetic flux of phi passing through the soft iron core without any leakages. Note that this magnetic flux, as established earlier, is varying with time, and so can be expressed as a function of time. This variation is usually sinusoidal, but we will not be concerned with that for now. To calculate the instantaneous voltage in the primary and secondary coils, by Faraday's law of induction, it is simply the change of magnetic flux linkage over the primary and secondary coils respectively, denoted here as phi-p and phi-s respectively. Next, it is easy to see that the magnetic flux linkage through the primary coil is just the number of turns multiplied by the magnetic flux through the soft iron core, or NP times phi, since each turn contributes to an area that the magnetic flux cuts through the primary coil. The resultant voltage over the primary coil is therefore NP times d phi over dt. Similarly, the magnetic flux linkage through the secondary coil is Ns times phi, and the resultant voltage over the secondary coil is Ns times d phi over dt. We can now see that the number of coils wound around the core is directly proportionate to the voltage produced by that coil, that is Vp over Vs equals to Np over Ns. This holds true at any point in time as the magnetic flux varies, and so this implies that the peak voltage of primary and secondary coils follow the same ratio. A step-up transformer produces an output voltage in the secondary coil that is greater than the input voltage in the primary coil. That means that there are more coils in the secondary coil than the primary coil. On the other hand, a step-down transformer produces an output voltage in the secondary coil that is smaller than the input voltage in the primary coil, and that means that there is less coils in the secondary coil than the primary coil. Now that you know the ratio of the voltage of the primary and secondary coil, what about their currents? Do they follow the same ratio? No, they do not. Instead, they follow an inverse relation. Why is it so? Again, assuming an ideal transformer, there will be no energy loss, so the electrical input power will equal the electrical output power. In other words, since power is given by Vi, Vp times Vi, Vp times Ip will be equals to Vs times Is. So the current is inversely proportionate to the voltage and hence the number of coils wounded. Although not physically meaningful, another way to easily remember this concept is with a simple analogy to two gears of different sizes interlocked with each other, having Np and Ns number of teeth respectively. When both gears turn together, the speed of rotation of the bigger gear will be slower than the speed of rotation of the smaller gear, and their speed will be inversely proportionate to the ratio of the number of teeth that they have. And this is similar again to how the speed of charges, which is current, in the two coils are inversely proportionate to the number of coils that are present. Of course, this does not explain why the mechanism behind the transformers at all, but only should be used as a memory aid if you want to.